Hey there, folks. I just want to walk you through this little demo of how electron excitation works. This is a simulation that I made when I was a student teacher in Flash, and very shortly it won't be able to run in your browser anymore, but I'm going to walk you through this. So we're heating up some lithium. What this is a little wooden stick with some lithium chloride or some sort of lithium salt on it, and here's a Bunsen burner, and we're adding some energy with a flame to those lithium atoms. So let's look. Here's a lithium atom, a typical lithium atom with its electron configuration of 2-1. Two electrons in the first shell, one in the second. When we add energy to some of those electrons might jump up to a higher energy level. So they might go through an excitation like this. Okay. You see that? That was absorption of energy by this electron, and instead of 2-1, now it's 2-0-1 for the electron configuration. An electron jumped from the second level up to the third level, but it's unstable up there, and it doesn't want to stay there because it's very unstable. So it's going to fall back. As it falls back, it releases energy of a certain wavelength. In this case, it emitted some red light with a red wavelength based on that exact amount of energy that was released when it fell back from the third shell to the second shell. Now, some other electrons might go through a different excitation. They might get excited from the first shell out to the third shell, giving it a temporary electron configuration of 1-1-1. Again, that's absorption. The electron absorbs some energy, jumps up to a higher shell, but it's unstable. It's unstable, and so it's going to fall back to where it came from. And as it falls back, it's going to release that energy. It's going to go through emission, emit that energy, and it gave off a different wavelength of light. It gave off some blue light. Now, there can be other types of excitations and emissions which release other exact wavelengths of light. And it turns out that this pink flame that we're seeing from lithium is the combination of all these different wavelengths. Now, the only thing I goofed up when I made this is I flipped the order of the rainbow, Roy G. Biv. Those wavelengths of light, normally red would be on the left and purple would be on the right. Let's run through this one more time. Here's a typical lithium atom. One kind of excitation could be jumping from the second shell to the third shell when the electron absorbs some energy from the flame. Then it emits that energy as it falls back to a more stable state, to the ground state. That's what that's called. It emits that red wavelength of light. Another excitation or absorption could be going from the first shell to the third shell. Then the electron falls back to the ground state by emitting some light in another wavelength. There are other excitations and emissions as electrons go up to the excited state and fall back to the ground state. Every time that happens, they emit a certain wavelength of light. Those wavelengths combine to give the unique flame color or flame test for lithium. Okay, thanks for watching.